The evolution of humans is perhaps one of the most complex questions we face today. From how we evolved to identifying our earliest ancestors, there is so much we still don't know. Among these mysteries, one of the most pressing has always been, who was our first ancestor, the first hominin to diverge from the hominid family tree? For over a century, since Darwin's theory of evolution, scientists have been searching for this answer, and they now believe they have found it in Sahelanthropus tchadensis. Dating back more than we could imagine, this species challenges everything we thought we knew about our family tree. But what was Sahelanthropus tchadensis? What implications does its discovery bring? And how did a single fossil change everything we've ever known about anthropology? The discovery of a new hominin is always an exciting time in science. However, the discovery of Sahelanthropus tchadensis was by all means a shocker. In 2001, Michel Brunet, a French paleontologist, led a groundbreaking expedition not in the famous Great Rift Valley of East Africa, but in the less explored Chad Basin, located in Central Africa. At the time, this wasn't a great idea if you wanted to find hominins, because the Great Rift Valley had long been favored by paleoanthropologists due to its wealth of fossil discoveries and clear geological history, making it a prime location for studying human evolution. However, drifting far to the west, Brunet chose the Chad Basin, a more remote and challenging environment, in search of evidence that could broaden our understanding of early human ancestors. The Chad Basin, situated at the southern edge of the Sahara Desert, was an environment far different from the more studied regions of East Africa. The Jurab Desert, where the team conducted their search, is harsh and desolate, with vast stretches of arid land and searing temperatures that can surpass 45 degrees centigrade or 113 degrees Fahrenheit. Its discovery not only added a new location to the map of human evolution, but also reshaped the narrative, showing that the path from ape-like ancestors to modern humans was more complex and widespread than previously thought. And all of this came from one single fossil, as Toumai is the only one of its kind that has been discovered to date. However, in 2005, the team announced additional jaw and teeth discoveries from Jurab. Although Toumai was a significant find, the fossil did run into some immediate problems. The first problem that Toumai ran into was dating. See, scientists needed to find out the age of the fossil to be able to categorize it into our family tree. However, the process was far from straightforward due to the challenges posed by the fossil's age and the environment in which it was found. Normally, carbon dating, also known as radiocarbon dating, is the most commonly used method for determining the age of organic materials. It works by measuring the amount of carbon-14, a radioactive isotope, in the remains of once living organisms. However, in the case of Toumai, there was a big issue. Carbon dating is only effective for items up to 50,000 years old. Toumai was much older, making carbon dating useless in this case. So scientists had to turn to other methods. The primary method chosen to be used was stratigraphy. At its core, stratigraphy involves analyzing the layers of Earth or strata where the fossil was found. To understand this, think of the Earth's layers as a giant layered cake. The oldest layers are at the bottom, and the newer layers are added on top of millions of years. By examining these layers, scientists can estimate the age of the fossils found within them. However, in the case of Toumai, the situation was complicated. The Jurab Desert, where the fossil was discovered, is an environment where wind and water erosion can mix up these layers, making it difficult to rely solely on stratigraphy. To make things even harder, unlike the Rift Valley, known for its volcanic activity and well-preserved stratigraphy, the Chad Basin was less understood, with its deep layers of sediment hiding secrets beneath the shifting sands. Against the odds though, after weeks of grueling work under the relentless desert sun, Brunet's team stumbled upon a remarkable find, a nearly complete skull, buried for millions of years. This fossil, later named Toumai, was unlike anything previously discovered. The skull, about the size of a modern grapefruit, was small with a flat face, prominent brow ridges, and a tiny brain capacity similar to that of a chimpanzee. The name Toumai was indigenous to the local Daza people of Chad, where the fossil was discovered. The Daza, an ethnic group native to Chad, live in the region where this ancient hominid was unearthed, and the naming was a reflection of their deep cultural connection to the land and its history. In the Daza language, Toumai means hope of life, which was a name given to children born at the beginning of the dry season, in hopes that they make it through the season and grow up. However, this name was also a fitting name for a find that would shed light on the very origins of humanity. The discovery of Toumai was a huge point of pride for the country. In fact, in an interview between the former president of Chad and Michel Brunet, the president was reported to have said, "The ancestor of mankind was Chaldean." The discovery was astonishing not just because of where it was found, but rather because of all the secrets it would reveal to scientists. Secrets that would challenge the prevailing belief that early human ancestors were confined to East Africa, and so much more. Toumai shocked the world, as it suggested that our ancient relatives were more widespread, roaming Central Africa as well. Its discovery not only added a new location to the map of human evolution, but also reshaped the narrative, showing that the path from ape-like ancestors to modern humans was more complex and widespread than previously thought. And all of this came from one single fossil, as Toumai is the only one of his kind that has been discovered to date. However, in 2005, the team announced additional jaw and teeth discoveries from Jurab. Although Toumai was a significant find, the fossil did run into some immediate problems. The first problem that Toumai ran into was dating. See, scientists needed to find out the age of the fossil to be able to categorize it into our family tree. To overcome this challenge, scientists used something called cosmogonic radionuclide dating. Complex name aside, this was a method that looked at specific isotopes formed by cosmic rays striking the Earth's surface. These rays are mostly from stars, especially those that went supernova. When these rays hit certain elements in the Earth's crust, they produce rare isotopes like beryllium-10. Now, this is a much more trusted method because once the isotope is formed, more cannot be formed, as there is no primary material to react with. This method was extremely accurate and was particularly useful for dating very old sediments where fossils like Toumai are found. For a much clearer picture, imagine the Earth's surface as a cosmic shooting gallery. Cosmic rays, high-energy particles from space, constantly bombard the Earth. When these rays collide with elements like oxygen or nitrogen in the ground, they produce isotopes like beryllium-10. The concentration of these isotopes in the sediment layers can be measured to determine how long it has been since the sediment was exposed to cosmic rays, essentially giving an age to the sediment. As you probably expected, beryllium-10 was one of the isotopes used in this method. It has a half-life of about 1.39 million years. For non-science students, a half-life is the time it takes for half of the radioactive atoms in a sample to decay. Essentially, this long half-life makes beryllium-10 ideal for dating sediments that are millions of years old. So to date Toumai, scientists have measured the beryllium-10 levels in the sediment layers above and below where Toumai was found. By doing this, they could estimate when these layers were last exposed to cosmic rays, providing an age for the sediments. The sediment layers above Toumai were around 6.8 million years old, plus or minus 400,000 years, and those below were slightly older, around 7 million years old, plus or minus 300,000 years. Now this was just insane because by analyzing the sediments and applying cosmogenic radionuclide dating, scientists concluded that Toumai was around 7 million years old. This places him at one of the most critical points in human evolution, which is shortly after the divergence of the human lineage from that of chimpanzees. Essentially, it is the oldest human ancestor we know of today. So what is he classified as? The classification of Toumai, the fossil of Sahelanthropus tchadensis, became a focal point of debate in the scientific community following its discovery and dating. Sahelanthropus tchadensis, translating to shellman from Chad, was one of the oldest known hominid fossils and was initially proposed as a crucial link in the human evolutionary chain. However, this classification was anything but straightforward. See, when Michel Brunet and his team first introduced Sahelanthropus tchadensis to the world in 2002, they suggested it could be one of the earliest hominins. They claimed it marked a significant stage in the divergence between humans and our closest living relatives, the chimpanzees. This assertion was based on several key features observed in the skull, which we will dive into later. However, despite its compelling features, the classification of Toumai as an early hominin was not universally accepted. In recent times, subsequent discoveries and analyses of other early hominins, such as Tchadensis and Ardipithecus ramidus, which also exhibit a mix of primitive and advanced traits, have fueled further discussions about the complexity and diversity of early hominin evolution. These findings point to the possibility that the evolutionary path leading to humans was not linear, but rather a branching network with many offshoots, of which Sahelanthropus tchadensis might have been one. Today, Sahelanthropus tchadensis is still often classified as a hominin, but with significant reservations. It is considered one of the oldest potential members of the human lineage. Yet, whether it is a direct ancestor of humans or part of a closely related branch remains an open question. As research continues, the position of Toumai in the human family tree may become clearer. But for now, it stands as a symbol of the complexities and challenges of understanding our deep past. But what do you think? So what did it look like? And why couldn't its features simply get classified as hominin? Sahelanthropus tchadensis was a very iconic species, as it presented a blend of both primitive and advanced anatomical features, which has made its classification challenging and sparked debate among scientists. Before we go on, it's important to note that scientists just assumed Toumai was male. The exact age and cause of death for Toumai are not definitively known. However, scientists estimate its age at death could have been around 11 years, based on tooth development and wear, which indicate juvenile characteristics. This can be done because analyzing teeth and bones can provide clues such as the eruption of molars or the fusion of growth plates to estimate age. As for the cause of death, possibilities include predation, injury, disease, environmental factors, or natural causes, though the fossil record doesn't provide clear evidence for any specific reason. Now down to anatomy, the skull of Toumai was small, roughly the size of a coconut, and from this, scientists could estimate its brain size to be about 350 cubic centimeters, which is similar to the size of a grapefruit. To put that in perspective, the brain of a modern human averages around 1,300 cubic centimeters, which is comparable in size to a small cantaloupe or a large grapefruit. This small brain size is more akin to that of a modern chimpanzee, highlighting how Toumai still retained primitive features more aligned with apes. Toumai's face, on the other hand, is relatively flat compared to many other early apes, and is somewhat similar in shape to the face of a bulldog, but on a much smaller scale. The brow ridge is particularly pronounced, like the heavy eyebrows you might see on a silverback gorilla, giving it a distinct, robust appearance. This heavy eyebrow is called the suborbital torus and is present in modern humans, but it's not pronounced. Unlike the protruding snout of a chimpanzee, Toumai's face is flatter, more like the front of a toaster, which is closer to what you might see in later human ancestors rather than great apes. Moving on to dentition, the teeth of Sahelanthropus tchadensis offer some interesting comparisons. For one, the canines are smaller and more blunt than those of many other early apes. You can imagine the canines as being about the size of a large pencil eraser, which is much less intimidating than the sharp, fang-like canines seen in chimpanzees or gorillas. This is more similar to what you'd find in modern humans, whose canines are also relatively small and non-threatening. The molars, however, are still relatively large and robust, similar to the size of a shelled walnut. This suggests that Toumai likely had a varied diet that required some heavy-duty chewing. However, it was not as specialized as later hominins like Australopithecus, which had molars that could be compared to small pecans in terms of size and toughness. Perhaps one of the most shocking features of Toumai was the position of the foramen magnum. The foramen magnum is the hole through which the spinal cord passes. This hole is quite important as it offers crucial insight into how Toumai might have moved. In Toumai, the foramen magnum was located more toward the base of the skull, similar to where it is in modern humans and bipedal animals like ostriches or kangaroos. This placement suggests a possibility of bipedal posture, although without leg bones to confirm this. It's like having a piece of a jigsaw puzzle that hints at the bigger picture but doesn't quite complete it. Leg bones were discovered with Toumai, but they however lacked ankles and knees, so they weren't much help. So, how does the placement of a hole show bipedalism? Well, if the foramen magnum were positioned at the back of the skull, like in a dog or cat, Toumai would likely have walked on all fours. But because it's closer to the center, like where you'd find it in a human or a meerkat, it suggests a creature that might have spent some time walking upright, although perhaps not exclusively. The overall morphology of Toumai is a mix of traits that make it challenging to classify. For example, the small brain size, combined with a face that is both primitive and somewhat human-like, puts Toumai in a unique position in the evolutionary tree. The mix of features is almost like finding a car that has a modern aerodynamic body, but an engine that runs like something from the early 1900s. It's a blend that doesn't easily fit into a single category, which is why scientists debate whether Toumai is an early hominin or a member of a different branch entirely. Essentially, the challenge in classifying Sahelanthropus tchadensis lies in the mosaic of features. It's like trying to decide if a hybrid animal, like a creature with the body of a fox, the ears of a rabbit, and the tail of a squirrel, belongs to the fox family, the rabbit family, or something entirely else. While the foramen magnum's position suggests it might have walked upright like modern humans, its small brain size and primitive features are more akin to those of modern apes. Moreover, the lack of postcranial fossils, bones from below the head, posed a significant challenge. Without leg or pelvis bones, it was impossible to definitively confirm whether Toumai was indeed bipedal, which is a crucial trait for identifying hominins. Further complicating the classification was the fact that some of the features used to classify Toumai as a hominin, such as the flat face and small canines, could also be found in other apes that were not direct ancestors of humans. This morphological variation led some scientists to argue that these traits alone were insufficient to classify Toumai as a hominin, suggesting instead that it could represent a side branch of the evolutionary tree that did not lead directly to humans. With that said, what was life like for Toumai? Life for Toumai would have been shaped by the diverse and challenging environment of the Taurus Manala region in Chad, around 6 to 7 million years ago, during the Upper Miocene epoch. This area was dominated by the ancient Lake Chad and surrounded by a gallery forest, creating a rich and varied ecosystem. Toumai most likely lived near a large lake with deep, well-oxygenated waters, swampy regions, and turbid waters. The surrounding gallery forest would have offered shelter and food. After all, the region was home to a wide variety of animals, including freshwater fish, turtles, lizards, snakes, and crocodiles. Large predators like extinct hyenas and saber-toothed cats would have also roamed the area, making life dangerous and competitive. On the other hand, mammals such as extinct forms of aardvarks, horses, pigs, cows, hippos, and elephants, as well as smaller animals like rodents, would have shared this environment. When it comes to its diet, the Toumai was likely an omnivore, with a diet primarily consisting of fruits, nuts, seeds, and leaves from the gallery forest. Its small, blunt teeth suggest it wasn't a heavy meat eater, but could have eaten small animals, insects, or even fish when available. The variety in its diet was essential for survival, especially in an environment that could fluctuate with the changing climate. While specific details about Toumai's social life are unknown, it likely lived in small groups, similar to other early hominids. These groups would have provided protection, social interaction, and assistance in navigating the many threats of the environment, such as predators and competition for food. Daily life for Toumai would have involved foraging for food, seeking shelter in the gallery forest, and avoiding predators. The lake and surrounding areas would have been central to its existence, offering both resources and dangers. The need to find food, avoid threats, and care for social group members would have been constant challenges in Toumai's life. So, what happened to Sahelanthropus tchadensis in the end? Although scientists are not sure, the extinction of Sahelanthropus tchadensis was a result of several intertwined factors. During the Upper Miocene epoch, the environment around Lake Chad underwent significant fluctuations. This included shifts in climate, with changes in temperatures and precipitation that altered the landscape from lush gallery forests to potentially more arid conditions. This transformation would have impacted the availability of crucial resources such as food and water. As the environment changed, so did the habitat, with periods of lake expansion and contraction further affecting the ecological balance. But that wasn't all, as ecological pressures could have also played a significant role in Toumai's extinction. This is because the presence of large herbivores like extinct elephants and hippos created intense competition for food and space. Additionally, predators such as saber-toothed cats and hyenas posed direct threats, particularly to younger individuals. This predation pressure, coupled with competition for resources, made survival increasingly difficult for Toumai. From an evolutionary perspective, Toumai might have faced challenges as new hominid species evolved and were better adapted to the changing conditions. The gradual disappearance or transformation of its ecological niche, coupled with the emergence of more adaptable species, most likely contributed to its eventual extinction. In essence, Sahelanthropus tchadensis struggled to adapt to rapidly changing environmental conditions and increasing competition, leading to its disappearance and leaving behind only fossil evidence of its once thriving existence. There is so much we don't know about Sahelanthropus tchadensis. However, as science continues to push the boundaries of what is possible, more and more should be uncovered about our oldest ancestors. Sadly, however, since 2006, the study of Sahelanthropus hasn't advanced all that much. No additional fossils have been discovered, or at least none have been publicly announced yet. But what do you think? Is Sahelanthropus tchadensis going to remain a mystery for much longer? Do you think it should be classified as a hominin? Or is it simply a prehistoric great ape? And what prehistoric animal do you want us to cover next? Let us know in the comments. While you're at it, why not hit the like and subscribe buttons to learn all about the wonders of prehistoric times? Until next time, stay curious.